An open rectangular box is made by cutting corners. Alright, so we've got this, we're going to cut these corners out and fold them up so that we've got an open rectangular box. So we're looking at volume there. And the score made by cutting square corners out of a square piece. It's originally a square piece of cardboard measuring 60 by 60. So you think this is 60. And so we need to have a look at how big these squares in the corner should be cut out. So let's make them X by X to start with. And you can see that if we do that, knowing that this is also 60, you can see hopefully that this length here would be 60, take away 2 x's, take away that x and that x. This would be the same, 60 take away 2x. Oops. And then of course this height here, which will, when we fold it up, will be the height of the box, will be x. So if I'm looking at a volume formula, I'm looking at 60 take away 2x times 60 take away 2x times x being my volume. Now perhaps instead of saying 60 take away 2x, I could say 2 lots of 30 minus x's. So that would be remembering timesing that twice and then timesing that by x. So if you think about it, I've actually got 4 30 minus x squared times x. And if I then wanted to expand that out, I'll put the 4x here, then I could expand the square out first. So 30 times 30, 3 3s are 9, that's 900. Take away double is 60x and plus x squared. So 3600 x's minus 6 4s are 24, 0x squareds, plus 4x cubes. So if we wanted to maximize this one, we would need to differentiate. So we're getting 3600 minus 480x plus 12x squared. And we may need to also do double dash because we want to show it's a maximum, not a minimum. So minus 480 minus 24x, have that already. Now, if we want to find a stationary point, of course, that's the first thing we do. Let's maybe factorize this by hopefully a 12. If I factorize it by 12, I'm going to get x squared. If I'm going backwards by terms, so looking at that term first, minus 40x would give me the 480x, nice, and 3, okay, so that would be 3, oh, why am I writing that again? Why? Alright, so try not to do what I do and go back to front. So is that what I'm doing? That's what I'm doing. Sorry, I was going to step ahead to this step and instead I did the right thing for once. Alright, but I stuffed myself up. So minus 40, I'm going to get minus 30 minus 10. That should work. Alright, so whoops. So remember, when I'm looking to maximize or minimize, I'm looking for stat points. So I need where v dash equals 0. So that would be where x equals 30 or 10. So looks like I've got 2 answers for that. Now, if I do look at v double dash of 10, I'm clearly going to get a negative answer. So negative 240. So negative 480. Oh, that's weird, isn't it? If I put 10 in, did I write that as a, that should have been a positive, shouldn't it? Apologies for that error. Alright, so that makes it better, so that's why it's minus 240, and that's less than 0, so it's gonna, that's where it's a maximum. So that's great, where if I do it for 30, I reckon I'm going to get a minimum. So I'm going to put 30 in here. So I'm going to get definitely a positive, that's going to be 240. So that's going to be a minimum. So therefore, we've got Vmax happening at x equals 10. Now, if Vmax happens at x equals 10, then what's the maximum volume? Well, we know the volume was, so if I put my x equals 10 back, so my dimensions are going to be 10 is the height by 60 take away 2 tenths, so that's 60 take away 20, so that's 40 by 40 because it's a square base. Therefore, the maximum volume will be 4 fourths is 16, so it's going to be 16,000. What are our units? Centimeters. So centimeters cubed for volume. So there's our Vmax. So make sure you do show that it's a maximum when you do these questions.